All right, so this video is going to help us understand how we can convert from 1 PSI to inches of water column. So how do we convert from PSI, pounds per square inch gauge pressure, to water column? And for it, we're going to be using a bottle of water. It's got an electronic scale here, currently zeroed out, so that it reads 0. And I have a column of, well, this happens to be made out of copper, but that is 1 square inch. So it's actually a piece of pipe. When you do the calculations, this pipe works out to 1 square inch of surface area at the bottom. And so we're going to fill up our 1 square inch pipe, and we're going to see how high 1 pound of water will make it in this cylinder. So 1 pound of water, a water bottle here, it actually has 16.9 ounces, and so not a little bit more than 1 pound, 1.115 pounds. So what we're going to do here is put our graduated cylinder up on the scale and zero the scale. And then I'm going to begin to add water. And what I'm going to do while I'm adding this water is zoom you in so that you can see the scale reading. Okay, so we're zoomed in on the scale reading. It's currently sitting at 0. It's going to read in pounds. And I'm going to slowly start pouring this water into the graduated cylinder. And we can see the pressure's going up, or the weight's going up. I wish this cylinder was clear so that we could see inside of it. Continuing to pour. Getting close. See if I can hit this directly on the money. Ooh, ooh, close. Almost. So we're so incredibly close. Now let's look at, we've got basically our 1 pound in. If we switch over from decimals, we're at 15.45 ounces, which is really close to 1 pound. And if we pull back here and take a look at our cylinder, we'll see it is filled right up to the brim. Now, this cylinder is 27 inches tall. So right here is the 27-inch mark for the cylinder. And down the side here, we have our graduated marks. So 1 pound of water stands up in a cylinder 27.7 inches. If we come down here, that means that halfway up, half of 27.7 is going to be just over 13. So right here, just above 13 inches of water column would be a half a PSI. And when we deal with fuels, down here at 11, so LP gas is supplied at between 11 and 13 inches of water column, and then we burn it right here at 10.5. But natural gas is way down here. So I'm going to try to turn it just a little bit. So for natural gas, we actually supply the natural gas to the home between 5 and 8 inches, and we burn down here at 3.5. So if we zoom out and look at the cylinder again, so we can see the full height of it. "13" halfway up would be the equivalent of about a half a PSI, or 0.5 PSI. Natural gas, we're operating our system down here in the 5 to 8 inches range, and then we're burning at 3.5. So somewhere around a third of a PSI, so 0.33 PSI is where we would be operating at for our gas system. But way down here, 3.5, that's about 0.25 PSI. So that's about a quarter PSI. So when you think about natural gas in homes, we're operating at very, very low pressures. And then if you think about the duct system, so a furnace blower motor and the pressure it can produce, most furnace blower motors actually operate down less than 1 inch of water column. So if 1 inch of water column is way down here, that means it's way under a PSI. So we're talking about very small, very low pressures. So hopefully this visual representation can help you see that 1 pound of water will stand up 27.7 inches high. So 1 PSI is equal to 27.7 inches of water column. And when we're dealing with fuels, we're going to be well under a half a PSI, and that's why we operate in inches of water column.